mixer network is always present at the input side. Mixer network is going to add the input signal along with your feedback signal. So here also we have two types of mixing. It is called as series mixing and shunt mixing. Series mixing means, you know, in series voltage gets added, so this Vs will be equal to Vi plus Vf. So I'm going to connect all the three voltage in series. I'm mixing them in series, which means that I'm going to add all the voltages in the available in the network. Voltages are additive only in series because they are going to be constant in shunt, right? So I'm going to use series mixing. I'm going to have all the voltages in a loop, so I can apply KVL and add all the voltages. Shunt mixing, you know, in shunt current gets added, so I'm going to mix it in parallel way, mix it across the network so that I can apply KCL at this node. IS and IF will be added, which will be going as input to your amplifier. So series mixing, shunt mixing. Series mixing means elements will be in series and I will be applying Kirchhoff's voltage law and I'll be adding all my voltage. Shunt mixing, elements are in parallel. I'll be applying Kirchhoff's current law and the currents will be additive. Because current will be same in series, the current will be additive only in parallel. So shunt mixing, I'll be using parallel connection at the input side, and for series mixing I'll be using a series connection at the input side because of the reason whatever I have told. So we are having series mixing and shunt mixing. So like sampling, there are two types of mixing your signal with the input signal. So the two mixing blocks are shown. So first one is called as series mixing and second one is called as shunt mixing. Okay, series mixing is also called as loop mixing. Shunt mixing, you know, it is called as node mixing. So that can be given the other names for the series and shunt networks. So any doubt so far? So we have seen three types of networks: the sampling network, two types, voltage and current sampling. Feedback network. The purpose of feedback network you have seen. What is the feedback fraction or feedback factor? And the feedback network will contain only passive components. It can be RLC, but predominantly if you are going to go for amplifier based circuits, we'll be having only resistance. We'll be having only R in our feedback network. And mixing network is present at the input side where I'll be having series and shunt mixing. Series mixing means I'm going to add voltage. Shunt mixing means I'm going to add current. So in that way, we are going to have the types of mixer network. So any doubts so far?